So now we're going to get right into some of the modeling enhancements, and there are a fair number of them throughout 2016, but I really just focused on a few. I have an hour to show you, so I kind of focused on a couple, and the ones I focused on here are some of them dealing with surfacing. So this new ruled surface command is a brand new command in 2016, allowing you to create just that, ruled surfaces, and it allows you to create both normal, tangent, and swept ruled surfaces. And I've kind of got 3 examples here shown. And the first one is normal, so the one on my left here, I've got this normal surface that was created right in here. And to create that, all I have to do is actually select an edge reference, and it will then create my surface normal to the surfaces that make up that edge that I selected. Tangent is another one, and you can see this one up top here. So it's kind of this outer surface that has been extruded out. That's a ruled surface, and that is referencing this edge, so this blue edge that I've got selected right here. Okay, so that's a tangent ruled surface. And then the third one is a swept ruled surface. And this one's a bit harder to see, but when we get into the demonstration, it'll be a little more obvious. This swept ruled surface is right down here on the bottom. And it's a little bit different than the other two in that it requires a different selection set. It requires a curve as well as a direction vector. So we'll get into that when we show the demonstration. The next one feature in dealing with surfacing is the boundary patch functionality, and I am really liking this one. Previously, what you would have to do if you wanted to create a boundary patch would be to select a closed loop, and then the patch would be created. Now, what happens now in 2016 is as you select each edge in a selection set, the surface gets generated. So you can see here, I actually only have half of my closed surface here selected, and you can see that there's already a surface displaying. So it's actually going to preview as you select, and as you select each edge, it actually refines the shape of your boundary patch. And I'll show you that as well. So now what I want to do is I'm going to flip over into Inventor and show you some of this functionality that I just quickly talked about. So this is the My Home tab, and very similar to in past years, or last year really, because it was introduced last year. The one thing that I do want to draw your attention to, and this is something I'm not as keen on, and I'm not using it as much for this reason, but it's up to you. I used to love in 2015 where I could hover over the actual button, and when I hovered, it would tell me which unit my standard template would be applying. And right now, that's not working like that. So I work between Imperial and Metric all the time, so I actually don't remember what I set last. So what I find I sometimes do is either just use the status bar to create my new files, or you can go over into this advanced panel. So this is shown along the right. I can configure my templates. So I can go in and I could see, oh, it's millimeters, great, I can use it. Or the other thing I can do is expand out this advanced window. And so basically I've compressed the basic side, and I actually get basically this whole directory, and I can navigate down and pick what I want. Or I still have access to all those buttons as well to create my templates. So it's really just an option in terms of use that you can use. The recent documents also has been enhanced a little bit, and I have to say I love the filters. So it really is a nice way now of filtering what you're looking at in the recent documents. You can choose to display parts or drawings or assemblies or everything, or you can search by recently opened, dates modified, all kinds of different ways to filter things. So then once you've filtered everything, you could also reset that back to the beginning. So lots of customizations in this, and in that training guide I mentioned we wrote for this, all of this functionality is discussed in detail. So what I want to do now is I'm going to open a part, and I actually have it in my recent documents. So I'm going to double-click on this ruled surface model, and this has got a bunch of surfaces already created. What I want to do now is just add some more ruled surfaces, just like those images I showed you. So I'm going to select the ruled surface option, and the new dialog box comes up. I'm going to start by creating a normal surface. I'm going to zoom in so you can really see what I'm doing here. And you can see as I hover my mouse over a closed edge there, it immediately creates my ruled surface. Okay, so it maintains that normal to the edge reference that I've selected. if I flip this, you might be able to see, you can see that. See how it's gone to the outside now. I can flip it to the inside. So you can do it like this. I can hit apply. I'm going to flip over to my top view here, and just, it might be a little tricky to see, but I wanted to just show you that it doesn't create it normal to the top of the part. You can see it's normal to the edges of the surface that are the surfaces that make up that edge reference that I picked. So you can see how it created that. Okay, so that's one of my, my ruled surface options. The next one is tangent. And I can go through then and pick a series of tangent edges. You can see I can go through and pick selected edges here. And for those of you that are keen, have a keen eye here and are used to using Inventor surfacing, you'll notice that this is grayed out here, this automatic edge chain option. And you can see that I have to manually select the edges as I'm going. And I'm honestly, I think that this might not be functionality that's the way it's supposed to work. So I'm hoping that this is something that they're going to change up, because selecting all the edges definitely isn't the most efficient way of doing it. But it is the only way to do it at this point. I'm going to extend that out 25 millimeters. And if I go again and orient to the top view, you can see how my reference edge that I selected is in blue, so it's right along there, and it maintains that normal from that edge, maintaining kind of the continuous curve from the faces of the surfaces that made up that edge. And there's my normal surface. So I'm going to click Apply here. And next I'm going to create a swept surface. Now when I select that swept option, you can go and see that it's asking for a sketch and a vector. So a little bit different. It's not just asking for the selection of an edge. I don't have any sketches in my model, so I actually have to cancel out here. And I'm going to just create a sketch that I can use to create this sweep. I'm going to create a 3D sketch, and what I'm going to do is just project some geometry and include it. So I'm just going to pick my edges all the way around here. And I've got a closed loop there, and I can go back into my ruled surface, select that edge. Now I need a vector. And so what they're asking for here basically is, okay, so you want to sweep that a surface from that curve, but in what direction? So I need to select a direction. I'm going to choose my z-axis, so it's going to stay in the same direction as the z-axis. So if I kind of orient again to my top view, I'm going to extend that out a little bit so you can see it. And you can see that that normal ruled surface, or sorry, swept ruled surface now stays in the same line as that z-axis vector that I chose. And I can choose Apply. Okay, so that is what I wanted to show you in terms of the ruled surfaces. Let's just do one little thing here. And I'm going to show you that patch option. And when I choose the patch here, you can see it's automatic chain, so it would automatically pick those edges, but I'm just going to disable that because I want to show you how it creates as you go. So you can see here that it's automatically now refining the shape of my curve. And when I select that last segment that closes the loop, it'll actually pop it into place. So a good test of when you're actually modeling, if that preview doesn't appear, you'll know that your surface isn't going to be able to be created. Okay, so I can hit Apply or OK, and that now has a surface. So at this point, then I could use any of my solid modeling techniques, use my thicken command to go and create my solid. But what I wanted to do now is just continue on my presentation so that we have time to get through everything else. So here it is just in kind of a final. I created the whole model starting with this one, and you can see the geometry, the solid geometry that I created using the thicken at the end of this. So the next environment that I want to talk about is the drawing environment. And there are some significant enhancements here in terms of creating your views. So a lot of flexibility here now in creating views, and you can actually create views directly from your model file. So whether it's a part or an assembly, you can go in and create your drawing view directly from there. So you can see my model browser at the top here. I can right-click on the actual file name and select Create Drawing View. So really easy way of creating my drawings. A new drawing view dialog box is created, has been used. So we'll go through that as well. And then the big changes in terms of orientation, how you orient that first view. So we'll also look at that. Format text dialog box has also really changed and given some additional flexibility where I'm sure all of you have said, you know, why hasn't there been bullets and numbering in the format text dialog box? Well, it's now there. So fantastic. Very excited about seeing that. In addition to that, there's the ability to create note styles. So you can go into your styles and standards and assign and create a text style for your notes, and then you can go in and pick that from the drop-down list. So it gives you a little bit more flexibility instead of always assigning the the different styles that you want. Text preview, and this is one that's very nice in the drawing environment. As you're typing text in here, it actually appears directly in the drawing view. Now, the same isn't true when you're using the text option inside of a sketch, but it is true in terms of the drawing. Leader text can be rotated now, and non-leader text can also be rotated. So this is one of the examples showing here. I can select on the placement point, and you can see I get this little rotation window there where I can drag that text while it's in Canvas. A lot of changes also to the annotation leaders and balloons. I don't get too much into this in the demonstration, just not enough time to do it all, but there is a lot of enhancements that are all covered in our training guide. One I wanted to share with you because it's kind of been this thing for me in all of the builds is when you create a leader annotation, you always would have to select your placement, then place again, and it would keep creating leaders off of leaders until you actually right-clicked and select, I think it was OK, and then the actual note or information would be added. Now you can actually refine that to be single segment only. So I'm sure lots of you are going finally to that because you can enable that. And as soon as you actually enable the leader text, if you right-click in your menu, you can get that command come up. And once you enable it, it stays enabled until you actually physically disable it again. In terms of balloons, a lot of different enhancements. Some of them actually span both annotations and balloons. Window selection can now be done, so you can drag a window around annotations as well as balloons to select them. And what's nice there is if you were to actually want to like align maybe your balloons, any information that is included in that selection window that can't be aligned, whether it's not a balloon, it would actually be removed from the selection set. So that's kind of smart, intelligent behavior there. And the alignment options also have been refined to add this to-edge option, which is quite nice. You can now align to an edge in your model. So if you want to select some type of edge, maybe it's a sketched entity or one of the edges on your model, you can do that so it lines up with that. Now it doesn't align directly to that line, however it stays parallel with it. Okay. And the next enhancement is probably one of the biggest in the drawing environment, and that's dealing with sketch symbols. They've added the commands now right to the ribbon, so I love this. Everyone's used to using the ribbon now, and now we have the insert and define commands right there, front and central for everything. And the biggest change now is this new symbol library that they've added. So really just starting to get used to this, but I can see that companies are really going to like the ability to create symbol libraries and be able to share them between users and everything. And when you go to place actually your symbol in your drawing, you can select whether you wanted a local symbol that would be only in your drawing or one that's from that library. So I'm going to actually demo that for you so you can see what I mean there. So now I want to focus again and flip over into Inventor. And what I'm going to do now is open one of my other files here that's in my recent documents. And this is just an assembly file that I have. It's, as you can see, it's of an engine. And what I'm going to do now is show you that very first command we talked about in Drawing Enhancements. You can right-click and select Create Drawing View. So I'm in my assembly, and I can immediately create my drawing. So I'm going to create create my drawing view, I got to select my template right away, and it immediately creates my base view and prompts me with that drawing view dialog box. So much of this is the exact same as it was in 2015. Because I actually created the drawing directly from my assembly, it fills in the file that's going to be referenced in my drawing. The representation options are all the same as they were in 2016 or 2015. And as well, all of your styles are the same. They just updated the icons a little bit, so you could hover your mouse over them. You can see hidden line removed, and your shaded options. So still the same options, just a little newer icon for them. And you have your labeling and your scaling as well. So what you're seeing, though, is their whole right-hand side of that old menu that you were used to is missing, and that's all the orientation commands. Now, if you look right in that preview that I am looking at here, you can see I've got this view cube now in my drawing. So what I can do is, just like in any 3D and modeling environment, I can actually select on edges, and it reorients my model completely, so my view. So you can see how I can flip things around and do everything I wanted to and did in the 2D environment. So I'm going to flip this back and just create my view on the front. I can also create projections. So you can see I can drag out and I can place my projected view in this way. I can also have access to these little manipulators. So any of these arrows that are off the model enable me to create a projection as well. So I can just select on that and it projects. And one of my favorite things here is that if you actually in 2015 made a mistake, I always found that I'd have to cancel out of the view creation menu and delete the view that I didn't want and have to go back in and create a view. Now they have these little X's on the view. So you can see I've got one here. I can choose X and it actually removes it. And I could create it again if I wanted to. I can go in and drag them to reposition. So that's kind of what I wanted to show you with that. I can change my scaling. I can reposition it. And you can see that I've got my view. I'm going to just refit this to my screen. And I can select OK to create my view. So there I've got my base view and two projections. So now that I'm in the the drawing environment, I can still create my base view. It's still the same drawing view dialog box that I just used. But what I wanted to just kind of highlight now is the one thing that was missing in that kind of view cube, or what we talked about so far, was the custom orientation. And this is still all available in the in the view cube. I can do this pull down menu here and select custom view orientation. And here it brings me over into the custom view, and it's the same as it was in 2015. So I could go in here, manipulate this in whatever way I wanted to, and select Finish Custom View, and you can see that it actually reorients that model. So I can't actually drag the view cube around in the drawing environment. I can select edges and corners and faces, but if I wanted to reorient it in a way that's kind of off of one of those planar edges, faces, I would go in and do that custom view. So I'm happy with this. I'm going to actually change and scale it up just a touch. I can move that down a little bit and everything. I'm happy with the orientation of this. And I'm just going to flip over into some of the other tabs. So in this model state, really most of the commands in the other two tabs have remained the same. They've just streamlined it a little bit. For instance, in the weldment area, now they've brought all the weldment commands together. So in last year it was divided into the two tabs. Now they're all together. So it just makes a little bit more sense. Display options, you can see here that they've, again, just streamlined it a little bit. And I can go in and I can display my tangent edges are on, so that's perfect. I'm going to flip back. I actually want a shaded view here, and I'm going to shade that model. So you can see how now I have that view. So now I have a couple views in my drawing, and what I want to do is annotate. And I'm going to actually just add a symbol, because I want to flip over and show you that new functionality. So I'm going to define a new symbol. So I'm using that button on the ribbon. And I'm going to do that using just simple text. Okay, and this is the new format text dialog box that we talked about. I'm going to go in, and I know that I want to change this to just a different size font. And I could type in my my note or my symbol, but I actually have it done in a Word document because there's a lot of text to type. So I'm just going to Control-C that out of just a Word document. So you can see over here there has been some formatting assigned to it. And what's really nice about this is that I can paste that in over here, and it actually assigns the same formatting as it did in Inventor. So you might like, or sorry, in Word. You might like that, you might not. So you could also go in and make a change to it. But there's no paste no paste with clearing the formatting, unfortunately. Okay, so I've got my my format assigned here now. I can also add the new fancy bullets that I'm so excited about. So I can add 3 bullets there and do it this way. And you can see I can actually read the whole text without scrolling. In 2015, there used to be a couple buttons down here, and these buttons would enable you to scale the size of the display. Now you actually have to do that with your mouse. So right now I'm holding my Control button and I'm rolling my middle mouse button on my, so you can see that it's actually reduced the size of my font so I can read it all. It's not changed the actual size of the font for the symbol, but it has made it a little bit more readable. So I'm going to select OK, and you can see that the symbol has now been created on my sheet. I'm going to click Finish Sketch, and I'm going to just add a name for this. And hit Save. So you can see, just like in previous versions, under the Drawing Resources Sketch Symbols, I have this blue Loctite symbol. So I could add this directly to my drawing as I did previously. However, what I want to do is I want to show you that symbol library, so the really exciting new thing that is in 2016. So I'm going to go in, right-click, Save to Symbol Library. So this is the new command. And when you go in here for the very first time from your systems, you're going to have an empty set of libraries. There'll be no libraries listed here. So you can go in and create one. So I'm just going to create a new one called, let's say, Assembly Instructions, and press Enter. And the first thing you're probably seeing is these are all IDW files, and that is exactly it. They are stored, all the libraries are stored as IDW files in your design data folder. So you can go in and actually modify those drawing files and change them as you needed to. So I'm going to save my Loctite symbol into the assembly instructions and hit Save here. Then I'm actually going to remove it here because I want to make sure you see that I have pulled it in from the library and not locally. Now that I've hit Define, I can go Insert. And you can see the Insert dialog box has changed now because it's giving you the option to pull from your local file, and right now there's nothing in there because I just deleted it, or your symbol libraries. And I have this assembly instructions library that I just created, and there is my symbol. And I can go through and scale it if I want, rotate it. I'm going to turn off my leaders, and a preview is always being displayed here. I'm going to select OK, and I can go in and place it. So I've got my one instance of that symbol inside my, my file, and I pulled that from the library. And when it's pulled from the library, it actually does create a copy of it in your local drawing resources. So you can see it's listed here. Okay, one question I get a lot of is, so my system administrator makes a change in the source library. Is my drawing going to always update that? And unfortunately, it does not do that. You would need to go in and download the blue Loctite again and add it to your drawing. So there's no associativity once it's been pulled from the library. Okay, so that's what I wanted to show you in terms of the drawing environment, and now I want to flip back over into the last section of my presentation, and the one where we'll spend a little bit more time is in terms of all of the CAD import options. So Autodesk has really made great leaps in terms of importability and interoperability with other CAD packages, and they've kind of called this AnyCAD. And the whole thing here is that you're able to pull in files from, say, CATIA, SolidWorks, NX, ProE, CATIA, or Trio, and bring that into the model and leave it as a reference model. So what that means is if one of your coworkers that works in CATIA makes a change to that model, you can then import that change and it'll automatically update because you've brought it in as a reference model. That being said, you still have the ability to bring the data in and convert it to a Inventor model and have it as a base solid where you would actually lose that reference. But the big AnyCAD kind of functionality and the exciting part is definitely the reference model. When all of this is done, it's done through the import option. So in previous years, if you remember, and you've done this a lot, the import dialog box was incredibly complex. There's tons of commands everywhere. They've really streamlined this. It's much more simplified now and with fewer options. So I will show you that when we get into doing a couple of examples, but much easier to work through. And in that same dialog box, you also have the ability to selectively decide what you want to import and bring in. So you have some flexibility in terms of maybe working with a CATIA assembly to pick and choose what you want to bring in. So we'll go in and we'll look at a little bit more of that. In terms of associativity still and working with other data inside of Inventor, is the ability to a lot more flexibility in working with direct AutoCAD files. So what you can do now are maintain that associative link with the DWG file. And what they call this is they're basically bringing it in as an imported underlay, an associative underlay. So we're going to talk a little bit about that. And you can see in this image that I've shown here, this YA base part that I'm kind of pointing at right now, that's a drawing file. And it's been imported into my drawing, into a part file, and it is going to be associative. So any changes made in the AutoCAD source document would reflect in Inventor. So there's kind of a couple different workflows that I can see customers getting really excited about in terms of what they can do with this functionality. And one of them is this ability to bring in the DW underlay, maybe a layout file, so a factory layout, and then in Inventor assemble to that layout and then have that associativity so that if changes were made in the layout that the actual assembly file would update. So I'm going to show you a little demonstration of that. And then another application that I could see customers getting excited about is straight model creation. So here is an example kind of just of a little part where I've used the layout or the drawing from AutoCAD, and I'm actually creating model geometry directly in Inventor. And if changes are made in AutoCAD, I can definitely then see it reflect the changes inside of Inventor. So I'll show a little example on that as well. So we'll get back over into Inventor. And what I'm going to start with is opening a CATIA file. So this is a CAD product that is not native to Inventor, of course. So I'm going to go in, I'm going to select this spark plug CATIA assembly and select open. So as soon as I select open, it says, well, I can't really open this, I have to import it. So it immediately brings up the import dialog box. And I talked about those two reference types, the import types, the reference model and the convert model. So previously, everything was converted. Now we have this reference option. So I'm going to import this CATIA by reference. I'm going to create and maintain all the solids. I'm going to keep the units from the source model. And I'm also going to flip over into this Select tab. And this is where I can selectively decide what I want to bring in or not bring in. So it's got a preview. I've loaded the model in. And it's basically allowing me to hover my mouse over any of these parts. And what I can do, just like you've seen in maybe the derive functionality, I can go in and exclude one of the components. And this wire component in my spark plug is just something at the very bottom. You can see the component down here. I'm going to exclude that from my import. And then I'm going to select OK. And you can see that it's working to bring that in. You can see I'm now in an assembly file, and I've now imported that spark plug assembly from CATIA. I can go right-click on here, and I can edit the import options. So that brings me back into the same dialog box. I can go in and say, well, you know, I do want that component, so I can add it again. and I could select OK, and I could include it. So I've just brought it into an assembly. But let's say you wanted to use this assembly as another component in maybe a top-level assembly. That all can be done as well by importing the data. Okay, so one of the other things that I know I've seen customers asking about is the ability to suppress the link or break the link. So there's two little options here. But what I want to first do is I'm going to show you how the associativity works. So I don't have CATIA running on my computer, but I've kind of done something here to simulate a design change. So I have this Sparkplug assembly. This is the directory where I have all my parts. And this was the part that it originally referenced. So I'm going to just rename this to old. And then I had one of my colleagues then create a new part and change that up a little bit. And I'm going to rename that to the existing name for the part that it's referencing. So it's just body.cat part. So I've just kind of simulated a design change. And when I did that, you can see now that I've got this lightning bolt displayed over in my model browser. So it's indicating, hey, something's changed in this assembly and you should update it. So I'm going to zoom in here and I want to make sure you can see the change. And if you kind of focus on this dome shape component here, and if I go up into the status bar and update, I'll do a local update, you can see that that dome shape has been moved. So the design's changed a little bit, and you can see that that change in CATIA has now is associative and has been updated inside of Inventor. So really great functionality now in terms of being able to do that. Next, what I want to do is show you some of the AutoCAD functionality. So I talked about the two different kind of workflows that people would get excited about. And the first one I want to talk about is that layout example that I talked about. So I'm going to start by creating a new part. I'm just going to save that part file as, let's say, factory layout. Okay, I'm going to save that. Okay, so I have that part. And I'm going to import that AutoCAD file. So if you look on the Create panel here, I've got it highlighted, the command. I can select Import. And I'm going to flip over here to up one level. I'm going to choose my Layout Example Drawing. And I'm going to select Open. So it's going to ask me immediately where I want to place it. So I want to place it, let's say, on my XZ plane. And I'm going to reference it to my origin point. And it'll bring it in. And this is a little message that comes up all the time that basically says, inserting AutoCAD DWG produces an associative underlay. Underlay geometry can be used by projecting geometry into the sketch. So it's just basically, it's informational. It's not an error. It's just informational on what's just happened. And you can see I now have that file as a part. So it's now in my part file. So what I want to do here is I'm going to save this file, and I'm going to go back out and create an assembly. So here I'm going to create an assembly file, and I'm going to bring in that factory. And where did I save it? Just go back to my factory layout part. Make sure I'm saving it in the right spot. Oh, looks like it was there. I can't see it. So flip back over into my assembly. I'm going to place it. There we go. I just must have missed it. And I can select Open. I'm going to use this as my granted component and just place one instance. So everything's great there. So now I've got my very first component in my assembly. And I can use this then as a basis to assemble to. So I'm going to place a couple instances of a table. So this is just a table that is on my factory floor. And what I can do here is then assemble them to the layout. So this might be a little tough to see because of just the relative scale, but I'll try my best to zoom in pan as I'm working. So I'm going to add some assembly constraints here to place the table Okay, and then I'm going to do some alignments. Continue this with, and now my table is placed, basically lays on top of the actual layout for that table. And I'll do the same thing with the other table. Great. And just align these up. And one more and I'll be all done here. And there you can see that I have aligned everything up. I've got my tables now placed directly on the layout. So that is basically taking an assembly that has previously existed, the table assembly, and brought that in and assembled it to the layout. Now what I want to do now though is I'm actually going to use that layout to create geometry. So I'm going to call this part screen. I want to make sure that my template matches with what the rest of the model uses. And I'm going to select my plane to place it on. Let's place that on the XZ plane. And everything looks good there. I'm now in my screen model, so I'm going to actually create some geometry now. I'm going to start by creating a sketch. The easiest thing here is just going to reorient. And to create my geometry, what I want to do is I actually want to, oh sorry, I think I've missed a selection here. Sorry about that. Screen, XY. Okay, there we go. And what I want to do now is use that geometry from that associative underlay. So this new command that is what you use to project is called Project DWG Geometry. So you can see it's brand new in the sketch dropdown. I can select this, and this little ribbon mini toolbar opens, and I can select my entities. So I can choose to project single geometry. So if I zoom in a little bit here, you can see I can project all of the entities that make up those circular reference poles that are going to hold up my screen. I'm going to do it on both sides here. And just do this. It looks great. I can close that up. I can then also project additional geometry. This time I'm going to use the Project Connected, and it's actually going to project the screen. So you can see I can just pick one entity in the connected series, get automatically selected. So you can see how all of that is created. So now I have some geometry created, some sketch geometry. Now I want to actually extrude. So I'm going to spin this a little bit so you can see kind of as I go what I'm doing. So I'm going to extrude my posts up 72 inches. That sounds interesting. What's going on here? I may have to, let's try this again. Extrude, let's extrude out the walls. Something seems to be happening with the way the sketch happened for the poles. You can see that I've actually created all the walls of my screen. So everything looks great there, and I could have gone through and done the exact same thing with my projected circles to create that. But what I really want to show you here is that associativity. So we talked about the actual DWG file. I'm going to save everything here so we have it all. And the DWG file I can make a change to. So again, similar to what I did with the Spark plug, I'm going to open my my directory that has my data, going to go in here. And what I brought in was this layout example. So I'm going to rename this one to old. And again, I had a colleague who updated this, so they just sent it to me, and now they can say they made a change, and I can go and rename that back. Now, we're at the assembly level, so it's not smart enough to say there's been a change to the factory layout. If I actually went back into the factory layout part, you can see that the lightning bolt is showing in terms of a design change. But over in the assembly, it is showing that the model does need a local update. So before I hit this local update button, I just want to show you, okay, so keep an eye on where the tables are located and the size of these screens that I created. And I'm going to select local update. And you can see that the tables moved and all the screens got a little bit longer in this one section. So that design change that was made in AutoCAD in terms of the layout reflected in the models the model geometry that I created, as well as the assembly constraints that I did to place those tables. So definitely some really great applications here in terms of doing your layouts. The next one I wanted to show you was in terms of maybe doing a little bit more modeling work. We did this associative underlay as one plane. You can actually bring in multiple underlays to actually create geometry. So I'm going to, actually I'm going to open a file, create a new file. And I'm going to hit create. I'm going to save this file as Associative DWG just to give it a name. And I'm going to import my AutoCAD file. So again, it's on the Create panel. I'm going to select Import, and I'm going to bring in this YA base drawing. So I'm going to select Open and bring that in. And I can select a plane to bring that in on. So I'm actually going to bring that in on my XY plane, and I'm going to bring it in with the center point. So it's going to work for a second to bring that in. And again, that message comes up saying that, yep, we've just brought it in, and you can use this to create geometry. And you can see that it's brought in at this point. What I can do here, and I didn't show you in the other one, but in the other workflow, it is also still functionality you can use. If you right-click on the drawing file, you can go in and change the layer visibility. So there's a lot of layers in here that I don't need, so I'm going to clear them out. And I'm going to import just my hidden edges, tangent edges, and visible edges. You can see it's simplified what I'm going to be looking at. So that looks great. Now if I actually go over and hover on my home view and select it, you can see that it's just reoriented. You can see which plane it is on and do it that way. So now I'm going to actually start the creation of my associative geometry. So I'm going to start a brand new sketch. Actually, before I do that, one thing I'm going to do is I'm going to relocate it. So you can kind of see how it's scaled it here. So if I actually zoom, let me see. I'm going to turn on my center point here, turn on my visibility. And if I do that, then you can see how my home view is actually scaled. So what's happening is the import of that DWG file isn't aligning with the actual center point of the model because of where the center point was on the actual drawing. So sometimes I find it comes in beautifully in the way that the drawing file was created, it positions it right, but you also need to know how to use these translation tools to relocate it. So what I'm going to do here is just zoom in, and I'm going to say let's relocate this to the center of the model, and I'm going to say now snap to, so snap that center point to my center point of my actual new part file. And now when I select my home view, it'll actually be aligned properly with the center point of my XYZ plane. Okay, so everything looks great there. So now what I want to do is go in and actually create my sketch. So I'm going to sketch on my XY plane. And I'm going to use that project DWG geometry. I want to actually project all my connected edges. So I'm going to actually project all of the outside edges on this view, as well as the outside edges on this view. and I can close that up. It's projected them. I'm also going to create a dimension, and this dimension I'm going to use when I create geometry. So if I create that dimension, you can see that immediately I'm prompted with a message saying that it's over-constrained, which makes complete sense because the dimension that I've created is actually already defined with the geometry that I projected. So actually, I want to accept this message and create a driven dimension here. So you can see that it's creating that reference dimension for me so that I can actually use it in my modeling. So I'm going to finish that sketch. If I right-click here, I'm going to change my dimension display to name so you can see it's dimension D0, and you can see in a minute why I want that. I'm going to extrude out my, my depth. I can drag that, but I actually want it to be associative with my drawing, so I'm going to enter the depth based on that reference dimension. So I'm going to enter D0 and create it that way. So now I have my base geometry based on that drawing file. Now, if you think about maybe creating the holes next, this drawing does not, the underlay that I've brought in does not actually give me what I want. So I actually need to create a second one. And this second one, when I bring it in, I'm going to bring it in on a different plane. So I'm going to bring it in on this plane. I'm going to try and reference it to this point and select OK. And again, here you can see this one. Again, you can see when I zoom out, all my geometry is over here and it was imported over here. So again, another example of why Translate is a good example of being able to move things around. So I want to locate that geometry by repositioning it. And I'm going to zoom in over here. And I'm going to locate it on this point. And then I'm going to snap it to the solid geometry. So let's see if I can get this with. I'm going to snap it over here. So you can see how now it's moved into position that will actually be useful to me. And I think that it actually didn't go to the right spot, so I can retranslate that. Okay, why is that not translating there properly? Translate, there we go. Locate here, snap to this very corner. There we go. So that looks perfect. And again, I'm going to use, I'm going to start a sketch. I'm going to create the sketch on this plane. And when I do so, I can go in again and project some of that AutoCAD data directly in. So I'm going to project this outside edge. I'm also going to project these entities on my circle. And I'm going to add some dimensions. And again, I'm just adding those dimensions to be used as reference dimensions. So they will prompt me for over-dimensioning, but that's okay. I want to maintain that and create my sketch. So you can see now that you can see they're all reference dimensions, but these are all dimensions now that I can reference as I go in and say create my fillets. So I could create the fillets on the four corners of my model, and that diameter, that radius that I want is going to be D3. So I can go over here and enter D3. And when I create that geometry, you can see now that my geometry is referencing the dimension that has been pulled from the AutoCAD file. And the same thing, I can go in and create holes. So let's say I want to create a concentric hole. I want to place it on this plane. I want to reference this edge as my concentric reference. And I can go in then and create, let's say, a counterbore and use these reference dimensions over here. So my outside diameter is D4. I can say D4. D5 is my inner diameter. And I can say, let's go through all and select OK. And you can see how it's created that hole in that position. Now, I could have taken this one step further. And inside my sketch, if I go back into my sketch, I could have gone in and said, well, I want the depth of that counterbore. So let's say add another dimension in here. I need to project first, project those two entities and dimension them like this. and create my reference dimension. So that's D16. Then I could go into my hole and change that up as well to D16 and choose OK, and I have my hole. And I could go through and do all of the holes in the exact same way. So all of that has been done. Now again, I want to simulate that design change. So I'm going to flip back over into just my Windows Explorer here. And you can see that the YA base, this is the drawing that I referenced. I referenced it twice inside my model. And I can go in and just rename that, say, old. Take the updated model and rename that to simulate my design change. Sounds great. I can go flip over here, and immediately you see the lightning bolts have appeared on both of the imported AutoCAD files. So here what I want to draw your attention to, I'm going to zoom in a little bit here. The change that's going to be made is that the depth of this feature is going to get a little bigger and the diameter on the hole. So as I hit the local update, you can see those two changes were made in the AutoCAD file, now reflect in the Inventor file. Okay. So this was one example where I imported the AutoCAD DWG underlay on two different planes. You can see at any time I could go in and actually turn off the visibility. So maybe when I was working on the second plane, I could have turned off that visibility of the first to eliminate that. I also can right-click on that and do that break and suppress link as well. So if I didn't want any changes to reflect, maybe if the change was made in AutoCAD, I could definitely do that. I tend to like to suppress the link instead of breaking, because if you decide that you're going to break the link, there's no way of bringing it back. So you'd have to actually, if you needed it back, you'd have to recreate everything with that associative link maintained again. So really, I think now let's just finish up things and flip back over into my presentation and just talk a little bit about some of the AOTG training materials. So in all of our books that we have, including the one for the update book that I've kind of just been showcasing, we have objectives written on each of the chapters. So it's going to give you an idea of what you're going to learn. If you're an instructor, it's a great way of, introducing a topic and then confirming that knowledge at the end. There's review questions at the end of each of the chapters as well. So it gives students a way of, testing their knowledge and making sure that those answers are, they learn the material. Instructor tools are also available, and with those they can get kind of an idea of the timing to teach each of the chapters, answers to the questions, and probably what my favorite is the overheads. So many of the courses that we offer have overhead materials that are included with the instructor tools, and that will allow you to then have that PowerPoint presentation similar to what I was doing when you're teaching a class. If the course that you're looking at has certification associated with it, there's also certification objectives listed in the training guides. In terms of the update book that we did, there are no certification objectives. In terms of what we have available now for Inventor 2016, so I've been working really hard at getting all this stuff out since March, since the release of 2016, and many of the titles are now available, and if not, they're right around the corner. You can see here all of the titles listed in blue are now available on our store. The sheet metal title is very close to release. I've finished all my work on it now, and just the editors are adding all the polish to it. So that should be out in early July, so keep an eye out for that one. And then the rest will be kind of following up for the rest of the year. And that review for certification will come out once we know Autodesk's 2016 certification objectives. So with that, I will hand it back over to Corrine, and she'll just finish up the presentation.
Great. Thank you, Jennifer. I just wanted to point out all the different formats that we have available for learning these courseware titles. So we have our printed training guides. We refer to them on our website and elsewhere as student guides. Then we have ebooks, which contain the same great content as the student guide that's in an electronic format. So if you prefer that way of learning rather than having a hard copy book, ebook is great, and you get that instantly for not once you make the purchase. And then new, which I really should have added on this slide, it's so new, are video enhanced ebooks. We don't actually have those available yet for the 2016, but I believe those are coming later this year. We have them available for version 2015. And so those are our ebooks with instructional videos throughout. And just to give you an idea of how amazing these are. Our Inventor Introduction to Solid Modeling Video Enhanced ebook has 159 videos in it. So imagine what for me, that would be the best way to learn, right? You've got your ebook and all the great content, and then as you go through, there's all these videos you can click on and play and listen, and they're really short clips, but they just really help you learn the material that's there. Yeah, and then we have the instructor tools, as Jennifer mentioned earlier. And some people do ask, do I have to be an instructor to purchase those? And you don't have to. If you would like to have the answers there, the timing suggestions, and feel that you could use those overhead presentation files that some of the books come with, you are more than welcome to purchase those. And then lastly, in our last slide here, I just wanted to let you know where you can purchase everything. So we have the Ascent eStore, AscentEstore.com. That first link there is our online secure eStore where you can make purchases for everything. And you can also, if you're on our website, AscentEd.com, you can also be linked back to our eStore that way. And both the eStore and the website have all sorts of helpful information, such as the page count of the books, the number of videos, if there's a video enhanced ebook, pricing, table of contents, and you can also download a sample chapter if you'd like to see what that book looks like. Our feedback information is there, so if you do have any questions, because I know we're running a little tight on time today, but if you've got some questions you think of later, do email us at feedback@AscentEd.com so we can get back to you. And also, we have a blog. I mentioned at the beginning of the call that Jennifer is one of our bloggers, so we do encourage you to follow her for any Inventor Courseware updates. So with that, Jennifer, I'm just going to thank you for your presentation and thank you, everyone, today for joining us.